This is part 3 of sections 5.1 and 5.2. So we're still working on our exponent rules. We're asked to do y to the 14th over y to the 10th. Notice that these have the same base. And if we look at our properties, property number 4 tells us what to do if we have the same base on the top and the bottom. We subtract those exponents. So this is going to be property number 4. Okay, and so we subtract those exponents, so that's going to be y to the 14 minus 10, which gives me y to the 4th power. And that should be my answer. Okay, 7 to the 5th power over 7 to the minus 3. I'm actually going to work this one two ways, okay? The first way, I notice that I have the same base, so I can still use the property I had above. I can still use property number 4 that says I can subtract those exponents, okay? So if I apply property number 4, I get 7 to the 5 minus a negative 3, which is the same thing as 7 to the 5 plus 3, which is 7 to the 8th power. That's not one that they'll want you to multiply out. Okay, so the alternate way, what I could do is I could use this kind of property right here, the one that says if you have a negative exponent in the bottom, it moves up to the top. You move the unhappy exponents. So if I choose to move this up to the top, I would have 7 to the 5th times 7 to the 3rd. So that's the property, let's call it number 5, although it is a combination of some of these, okay? It's just, if it's in the bottom and it's negative, it moves up to the top. Now what we have here, we have the same base and we're multiplying them together, which means property 1 applies, which means I add those exponents. So if I apply property number 1, I get 7 to the 5 plus 3, which is 7 to the 8th power. This is what I mean by you'll often have several potential first steps and you'll end up with the same answer, okay? All these properties are interrelated. They all come from the definition of exponents. And you'll find this kind of thing a lot, okay? Let's simplify y to the 5th over t cubed. I notice that I have different bases, so let's see if I can find anything. This allows for different bases, but I don't have negative exponents, so it doesn't apply. This allows for different bases, but it's not being raised to a power. This one requires that you have the same base, and we don't. Actually, none of these apply. This one's already simplified. If you think about what I said about what it means to be simplified, no parentheses involved here, we do not have repeated bases, and we do not have negative exponents. So that one's already perfectly okay. All right, so let's look at negative 2x to the 5th power, in parentheses, raised to the 5th power. Okay, we're going to need a combination of properties here as well. This one's an example of one that people often can do in their heads. Like they can go from here to the answer. You don't believe me now, but you'll get there. What I mainly have here are two things multiplied together raised to an exponent. Property 8, I have two things multiplied together raised to an exponent. And it says I take that outer exponent and I put it on each individual thing. So I'm using property number 8. So this is the same thing as negative 2. You need to keep the parentheses, raised to the 5th power, times x to the 5th, raised to the 5th. Okay. So negative 2 to the 5th is one you probably would be asked to multiply out. Okay, if you're multiplying an odd number of negatives together, you're going to get a negative answer. Okay, Then you do 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I have negative 32. And of course, you could use your calculator. Make sure to keep those parentheses because they often matter. And you get negative 32. Now I have to deal with this part. Okay, I have an exponent raised to an exponent. This is going to be property number 7. Property 7 says you get to multiply those two exponents together. So in this step, I'm using property 7. And I get negative 32x to the 25th. And that's my final answer. Okay, these two properties, actually these three properties, are often used together. Okay, a lot of these problems, you'll start out using one of these two properties, and then you're going to end up using this one somewhere. Okay, so next page, maybe. All right, so again, a bigger problem. Y to the negative 2, z to the 4th, raised to the negative 3. Okay, you have a lot of first options. I could simplify inside first because I have a negative exponent that can move to the bottom. I could deal with this whole thing and move the whole thing down to the bottom and raise it to the positive 3 power. Or I can use property 8, and take that outer exponent and apply it to each one. This is really what I want to do. And that I'm just giving you a hint here. All those others will work, but this outer exponent, when it's negative, changes the signs of everything on the inside. So what usually happens is if you start fixing this, you're going to have to fix it again once you deal with this outer exponent. So I strongly suggest you use property number 8 first. That takes that negative 3 and applies it to each one. So this will be y to the negative 2 to the negative 3, and z to the 4th to the negative 3. Okay, now we have a property. We can use property number 7. They almost always go together. Okay, property 7 says a power raised to a power, you multiply those exponents. So I'm going to have y to the negative 2 times negative 3 is positive 6. This is what I mean. If you had fixed this earlier, you're going to find that you never needed to fix it at all because it ended up with a positive exponent. Okay? And then we have z to the 4 times negative 3, which is negative 12. Okay? We're almost there. No parentheses left. We do not have repeated bases. If I had a repeated base, I'd be able to combine them using this property. But I don't. But I do have a negative exponent, and that means the z term is going to move into the bottom, and we get y to the 6th over z to the positive 12. And this is property number 3 I just used here. Okay? All right, so a harder one. There's a lot going on here. I have 3rs to the negative 2. I have 3 squared, r squared, s to the negative 4. A lot of first steps, but the first thing I see is the same as what I saw on the problem above. When I have things multiplied together raised to an exponent, I really like to do property 8 first, well, almost always. Now, I mentioned in the first video of this section that this is written with 2 things multiplied together, but it applies to 3, 4, a million, 2 million, 573 gazillion, whatever number you want to think of. As long as it's all multiplication inside the parentheses, this works. Here I have 3 things multiplied together, and so each of these will get that negative exponent when I apply property number 8. Okay, so I get 3 to the negative 2, r to the negative 2, s to to the negative 2. I used parentheses here because if this happened to be a negative, it would really matter, but it doesn't matter in this step, really, because 3 is a positive number. And I'm just recopying the bottom. Okay. Now we can start moving things around. I can move this to the top, this to the bottom, this to the bottom, that to the bottom, and then combine all my exponents. It's probably easier, it is definitely easier to use property number 4. Since we have the same bases, we can subtract those exponents. So we'll combine them and then we'll deal with any negative exponents in the end. Okay, so I'm using property number 4 here. And I'm just going to subtract those exponents. If you look at property 4, it's always the top exponent minus the bottom exponent. So let's be careful with that. This is 3 to the negative 2 minus 2. This is r to the negative 2 minus 2, top number minus bottom number, times s to the negative 2 minus a negative 4. Okay, and just to save some space, that's the same thing as negative 2 plus 4. Okay, now just using the arithmetic, we have 3 to the negative 4, r to the negative 4, s to the positive 2. Now we're going to move these negative exponents down into the bottom, so we're using property number 3. And we get s squared, because that one was happy, it's staying in the top where it is. And then I have 3 to the 4th, r to the 4th in the bottom here. 3 to the 4th is right on the border of whether or not they'll want you to multiply it out. It's not so hard to do in your head if you think of it the right way. If I did 3 times 3 times 3 times 3, and I did it in order, 3 times 3 is 9, 9 times 3 is 27. A lot of us would get stuck trying to do 27 times 3 in our head. But if you think of it this way, where you group those together, you end up with 9 times 9, which is 81. So this answer, if they tell you to leave it in exponential form, this is what you want. If they expect you to multiply it all the way out, s squared over 81 r to the 4th.